I prepared a video for this session, and it's a 5 minutes video introducing one of the equipment in our lab and what we're doing in Smart Lab at BT. We have a lot of other equipment also, and I'm more than happy to answer your questions regarding other equipment. Let's play the video first. Okay, so our name is BT Smart Lab. SMART stands for Smart Manufacturing Analytics Research and Technology. In this lab, we build smart machines that can collecting ECG data while during the manufacturing process. We use the sensors in our system to collect the processing signatures and use machine learning to correlate what we have collect, the data we have collect to the material final quality. In this case, we use a machine that's doing selective laser melting, which is a type of 3D printing strategy. This strategy uses a laser beam to melt layers of powder onto a substrate, and if we do that layer by layer, a material, a block or a geometry can be added up, and this is a example of the printing result. And we can use the sensors to monitoring what is happening and optimize the printing strategy. So this, I'm using my hand to point out the laser generator, the water chiller, everything's cooled by water, and this blue box redirect the laser to the printing surface, so we can have a 2D printing surface for every layer. And after that 2D is done, we move the table and add another layer of powder, so we can have 3D geometry. And this whole chamber equipped with a lot of feed-throughs that we can put different type of sensors inside, for example, fiber optics, and we can also put motors and other actuators inside to move the stuff. And the printing is done with the argon protection gas environment, and that is the argon inlet. And as you guys can see, there's a lot of small holes underneath, which gonna release the argon and push all the oxygens from bottom to top. And we use an oxygen meter to monitoring the oxygen level. The green color one is the oxygen meter. And once it hits the number that we want, that controls the oxygen level to the correct amount, we start the printing. And this is the oxygen outlet while the printing is start, so we can vent the smoke outside without contaminate the lanes on the top. And the big blue box is a controller which controlled by the computer, and the computer can define the printing strategies. For example, what printing pattern should we use, what laser power, and what laser speed, moving speed, spot size, etc. We can control all those, and from the screen we can monitoring what is happening on the surface. And my hand is pointing as a DIC right now, which is a machine that can monitoring the distortion. And the green little machine with cameras on it is a 3D scanner, and we also have a thermal camera here. So by collecting all these data, we are able to in situ monitoring the entire printing process with multi-physics, and use machine learning algorithm to read those data and optimize the printing result. This is a sample. this is a sample that's printed by different parameters. As you guys can see, the different parameter will result different surface finish. And there are surface finishes very nice, which is the left bottom corner one, and the others are not that good. So we're trying to avoiding those by in situ monitoring the printing process. Oh, one addition thing is other than this laser printer, we also have different types of other 3D printers in our lab. They have advanced capabilities such as bioprinting, and we also have robot arms, like industry grade robot arms, and a lot of different type of sensors in our lab for doing the experiments. And previously, I was leading a group of undergrads to mentor them to use the robot arm to printing filaments with 3-dimensional, and the robot arm is doing 6-axle printing. That is actually a more complicated way compared with normally printing strategy that is done by 2.5D. The half D is because the Z direction can only be going positive, not negative. Oh, the lab is located at Durham Hall. This lab is not totally open to the public. I mean, it is for everyone, but since there's a lot of dangerous stuff inside, there are heavy machinery and very powerful laser inside. So to use the lab, the personnel needs to be pass a series of training. And for conducting research in this lab, please contact Dr. Call, and his email is zcall@vt.edu. All right, then let's call it a day. And welcome. Thank you guys for coming in today. Bye.